Welcome guys. Now let's start our new topic. One of very important components when we study the protection and control circuits is circuit breaker and isolator, and I thought that I should prepare a separate lecture on these topics so that you will be able to understand these two important components. Okay, circuit breaker. What is circuit breaker? Circuit breaker is on-load device that is used to break fault or load current. Another definition: circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. So there are two components for controlling that are mainly used in the substation. One is breaker, another one is isolator. Sometimes we are calling it circuit breaker, sometimes in protection engineer we are calling it CB. What is the status of CB? And sometimes you can also call it simply breaker. Miniature circuit breaker that we already know, which are in our houses, also a breaker, but in our production philosophy we are never calling it as a breaker. We are calling it MCB. Always we are calling it MCB to differentiate from the main breaker that is used to control power circuitry at medium voltage, high voltage and extra high voltages. So this is how the protection philosophy we are using this term, especially like this. So breaker is basically a device. For example, if there is a fault, then it will break the fault current. It is designed to break the fault current, and if we want to interrupt the power, for example you want to switch off, you can use this breaker also. In houses we are seeing a simple switch to on and off, because at low levels you don't need a specialized interrupting units to interrupt the current, but at high voltages and high currents special mechanism and special arrangement is required, and especially interrupter unit is used to break the load current. Otherwise current will not be braked, and the fault current or load current will be continuous spark, and it can damage the breaker. So this is the circuit breaker. So if anyone asks you, you can tell that this is an on-load device. This is how 132 kV circuit breaker look like. If you see, this is the structure, this steel, this is called as a structure, and here you can put bolts and you can put it on the foundation. This is called as a circuit breaker mechanism box. Here you can find circuit breaker mechanism and controlling circuitry. This is basically the pole. We are calling it the pole of the breaker. Mechanism will operate and push the interrupter inside these poles. So there is a mechanism like this. It will open when we want to interrupt or interrupt the breaker. There are two types of breakers where there is a common mechanism which is driving these poles to interrupt the current. It's called three-pole operated breakers, and the breakers where each pole has its own mechanism to open, it is called as single pole operated breakers. At extra high voltages, normally single pole is used at 220 or 380 500 kV level, whereas on 132 kV, in some cases 220 kV and below, single pole three pole mechanism, it means there is a single mechanism to drive these three poles is used. Okay, each circuit breaker when it operates has its own auxiliary contacts. This we have already studied in part 1 about the auxiliary contacts. It has its own auxiliary contacts. These contacts for the circuit breaker especially, we are calling it 52A and 52B. 52 is a code for circuit breaker, and A and B are two contacts. A are normally open contact and B are normally closed contact. This we know from our previous lectures. So if you are not able to understand anything, always go back and just attend my first lecture. So this is NC contact, means breaker normal position is open position when breaker is open. So breaker is shown open in the drawing, so this contact will be closed, this will be open, this will be closed, this will be open. So these are the contacts of breaker are shown. So you can see this is your assignment to find that what is the meaning of arrow here. This I am keeping for you. In later lecture I will obviously answer. Okay, circuit breaker auxiliary contacts. I have prepared some text so that you can in future read it. I'm always in my lectures first putting the text and then explaining my own words so that you can remember it. So let's read the definitions. Every breaker comes fitted with an auxiliary switch. It is mechanically linked to the breaker trip close mechanism. Within the auxiliary switch case, you can have either form A contact 52A or form B contact 52B. A form A contact presents a normally open contact. Thus, when the breaker is open, its 52A contacts are open too. When the breaker is closed, 52A contacts are closed. The 52A contact follows the status of breaker. So we will not be showing that this is NO or NC contact. The breaker contacts are shown like 52A and 52B. A form B contact presents a normally closed contact. It operates exactly opposite of what an A does. When breaker is open, the 52B contacts are closed. When the breaker is closed, the 52B contacts are open. So this is the definitions. You can always keep with you. If you are in confusion, you can come to this slide. Okay, here just for your understanding and increasing the conceptual view, I have shown here the circuit. This is the circuit breaker mechanism. Here you can see, and there is and it is connected to this black box in which auxiliary switches are available, and it is connected through shaft. So when breaker is open, the position of this shaft will change. It will from here, it will come up to here, and this contact also move. So in this way auxiliary contacts are operated. So if you are in inspection and somehow this rod is broken, so even the breaker contacts physically are changing, the auxiliary contact will not change. This is just a hint for troubleshooting. And you can see here, let me zoom, you can see this square box. This is used for adjustment of these contacts. So if for example the status is not coming accurately, you have the option from this, you can calibrate it so that the contact status is shown correctly. So this is used for calibration. So this is the little bit introduction about the breakers. So we'll move to our next topic, which is isolator. So another important topic, or another most important equipment for use for switching, is isolator. Isolator is off-load device. It is used to isolate the circuit for maintenance purposes. Isolators are used to open circuit under no load condition. Its main purpose is to isolate one portion of the circuit from the other, and it is not intended to be open while current is flowing in the circuit. So isolator main purpose is to isolate the circuit for maintenance. This is one of the main purpose. Another purpose of the isolator is for, I have not mentioned here but I can tell you, is for make the switching. By using the isolator, you can select the bus bar, you can select the feeders, which bus. So it's also controlling the power. Using this isolators, you can control the power, you can direct the power also, but provided that you should not use this isolator under load condition. It means the breaker, isolator is always mostly in series with the breaker. If it is in series of the breaker, the interlock must be present, that if breaker is closed, it should never be able to open it. And if, for example, it is used as a bus coupler and there is no breaker, the interlock should be present, that both buses must be de-energized, not connected with any source or feeding current, if you want to operate this isolator. This is basically, you can see physically how isolators look like. These are the contacts of the isolator, and these, you can see, these are the corona shields, which are basically to bypass the arc. There are two type of isolators. One are which are open and close horizontally, and in another type the contacts are closed vertically. In the same way, isolator also have auxiliary contacts just like a breaker, and they are also showing the status of the isolator. So these are the one of the two important components that you will mostly see in the drawings and their auxiliary contacts. So I hope you enjoy the lecture, and then you can always check the drawing, give the proper time to understand these components. So I will keep on explaining it, and so you will be able to understand easily. So thank you very much.